Welcome to MOOC's module on graphics and animation development. Outline of the contents to be covered in this topic are color theory, color models for images, additional contents like primary, secondary, composite and tertiary colors, device dependent and device independent color models, additive and subtractive colors, RGB and CMYK color models and certain limitations of RGB and CMYK color model. So, let us see first of all what is this color theory that is needed for designing any kind of graphics. Color is a light achieved by combining together all the available colors in the visible spectrum. Colors can be described as a sensation produced in our eyes by light of different frequencies. Say for example, blue color is generated by higher frequencies and the red color is produced by the lower frequencies. An object appears to have certain color because it absorbs the color components from the white light and reflects only light of frequencies specific to that color to our eyes. And due to this, object appears to be a specific color. Further, color models represents color information using certain numerical values, and it also helps us in recognizing and communicating the color information related to any graphics. Primary colors can be combined together or mixed together for getting colors that we see and recognize around us. Generally, color models defines a set of primary colors and other colors which are expressed as combinations of the primaries. There are further two different type of colors, composite colors and secondary colors. Composite colors are produced when we are mixing together primary colors in varying proportions. This provides us the way to describe any abstract color by specifying the name and proportion of the primary colors from which it can be produced. Secondary colors are further produced when the two primary colors are mixed in equal proportions. So, a color model is defined as a set of primary colors along with all possible composite colors. Secondary colors that we can achieve from the primary colors. So, from the three primary colors we can create three secondary colors with a mixture of any two primary colors. They are orange obtained by a mixture of equal quantities of red and yellow, green derived from a mixture of yellow and blue, and violet which is the resultant mixture of the blue and red. In this manner secondary colors are produced and they are indicated in this color wheel by the capital S letter. Tertiary colors that we can achieve from the primary and secondary colors. We can further create 6 more colors known as tertiary colors which are obtained by mixing together primary and secondary colors. We can take some examples like red orange, red violet, blue violet and so on, and these colors are represented by the capital letter T in the color wheel. There are two type of color models which we generally make use of while designing any specific graphics: device dependent color models and device independent color models. These models, which are generally referred as device dependent color models, make use of colors that are dependent on the physical properties of devices which generates them. For example, physical or chemical properties of CRT phosphors or inks. So, RGB and CMYK are the examples of device dependent color models. Red color is generally represented by the RGB integer triplet 255,0,0, but red color display will vary from one computer monitor to another depending upon its color space that it is utilized. Device independent color models. Device independent color models are based on the human perception of colors rather than the device properties. For example, HSB. HSB color model is using hue, saturation and brightness as the primaries. Gamut is further defined as the total range of colors covered by a particular color model. So, different color models have different gamuts. So, it may not always be possible for us to accurately convert a color from one color model to another color model. Additive colors. red, green and blue primary colors are combined for creating colors in additive color model. TV and computer monitor makes use of such kind of method for producing the colors. Similarly, red, green and blue colors are also known as primary because they cannot be produced by a mixture or combination of any other color. Subtractive colors. Color media such as paint or ink are combined for generating a new color in subtractive color method, and it absorbs some part of the color spectrum of light and other colors are reflected back to our eyes. For example, in printing we make use of subtractive colors. RGB color model for CRT displays. When the red, green and blue phosphors in CRT displays are excited with electrons, a combination of wavelengths is produced. A color image which is generally defined as a two-dimensional array of RGB integer triplets which encodes the amount of phosphors that needs to be excited in devices like monitors. So, in this figure we can see there are two color cubes, one is representing the RGB and another one is representing the CMY color model. So, here at the origin black is represented as 0, 0, 0 and white is represented as 1, 1, 1 and it works on the principle of additive colors. Similarly, in the second figure we are having CMY color cube and it is a reverse of this. At the origin we are having white as representation by 0, 0, 0 and opposite to this we are having the coordinate representing the black color which we are getting by mixing cyan, magenta and yellow as 1, 1, 1. So, it works on the subtractive colors. From these two figures also we can understand that how additive and subtractive color principle works for generating the colors. CMY color model for images. In CMY model, CMY stands for cyan, magenta and yellow referred as complementary colors of RGB and these can be used as subtractive primaries. This model is quite popular for printing devices in which the color pigments on the paper absorb certain colors. Further, in CMYK color model, K stands for black which is used for printing and it is used to produce darker black as compared to the black color produced by the CMY color model colors. So, we are having certain limitations also that works with CMYK and RGB color models. RGB designs printed using the CMYK color model does not produce the same output because the CMYK color space does not include all the colors that are available in the RGB gamut, but vice versa is possible and we can work out on that, and in the given figure we can have an idea about the gamut of different color models like RGB and CMYK and other color models. So, in this session we have covered the basic color models that are generally used for designing any graphics, and we will have to make an appropriate choice depending upon the type of application that we are going to design, whether it is for print mode or it is for the online mode. Accordingly, we can suitably make use of the color models and we need to understand the principles of color theory. The learners are advised to go to the given references here so that they can understand in depth the various topics covered under this session. Thank you.